Hello, Algebra 2 students. It's 2021 and I'm still making YouTube videos because I'm quarantined. We're about to start chapter 11, which is probability and statistics. The PowerPoint is from a different book, so it says chapter 7, but this is really your chapter 11. I have the full PowerPoint put in Canvas for you, so you can look at all of the slides. I'm going to do a basic overview for permutations and combinations. Today's objectives: we are going to solve problems involving the fundamental counting principle, and we're going to solve problems involving permutations and combinations. So let's take a look at our first example, and we'll be using the fundamental counting principle. To make a yogurt parfait, you choose one flavor of yogurt, one fruit topping, and one nut topping. How many parfait choices are there? Okay, so the fundamental counting principle lets us basically use a shortcut. Instead of making a tree diagram and counting all the possible outcomes, we can just count how many options do we have in this first category. For flavor, we have plain and vanilla, so that's 2. In the next category for fruit, we have peaches, strawberries, bananas, raspberries, and blueberries. So that's 1, 2, 3, 4, 5 options there. And in our last category, nuts, we have almonds, peanuts, and walnuts. So there are 3 options. The fundamental counting principle says we can take the number of flavors, which was 2, and multiply by the number of fruits, which was 5. Times the number of nuts, which was 3, and that gives us our total number of choices for different kinds of parfaits that we could make, and there would be 30 different parfait choices. So that is our fundamental counting principle. We just multiply. Okay, second example using the fundamental counting principle. Here's where we're looking. A password for a site consists of 4 digits followed by 2 letters. The letters A and Z are not used, and each digit or letter may be used more than once. How many unique passwords are possible? Okay, so our password has 6 spots to fill. Digit, 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 letter, letter. For the first spot, we have digits 0 through 9, so that's 10 options. And because we can reuse digits in our second spot, we still have 10 options. We have 0 through 9. Same thing for the third and the fourth spot. We have 10 options. But the fifth and sixth spot have to be letters, but the letters cannot be A or Z. So we have 26 letters, but 2 of them we can't use, which leaves me with 24 options for my 5th spot and 24 options for the 6th spot. So to figure out how many unique passwords are possible, we just multiply 10 times 10 times 10 times 10 times 24 times 24, and we find that there are 5,760,000 possible passwords. Okay, so there are more examples in the PowerPoint if you want to check them out, but we're going to move on to permutations. Okay, so permutations, we're looking right here. A permutation is a selection of a group of objects in which order is important. Okay, so permutation, order matters. Let's look at the formula. All right. For a permutation, the number of permutations of 7 items taken 3 at a time is, and here they have the numbers filled in for you, but this is your generic formula. We have the capital P for permutation, and then a subscript of an N in front of it, and a subscript of the R after it. Okay, so this is our notation. Is equal to, we do N exclamation point divided by, in parentheses, N minus R close the parenthesis, exclamation point. That exclamation point means factorial. Okay, so I'm going to go back for a second to show you what a factorial looks like. Okay, here we are. Factorials. If you saw a 6 with an exclamation point after it, that means we want to do 6 times the previous number in front of it. So that would be 5 times the number in front of that, 4 times 3 times 2 times 1, which gives me a total of 720. Okay, back to permutation formula. Let's do this example right here. How many ways can a stylist arrange 5 of 8 vases from left to right in a store display? The key word here is arrange. Okay, so that lets me know that the order matters and I should be using a permutation. The n has to be the bigger of your numbers. Okay, so it's like, how many objects do I have to choose from? And the R is how many objects are we taking at a time? Okay, so the 8 has to be the N, and the R is going to be the 5. So when we're plugging it into this formula right here, I'm going to replace all of these N's with 8s, and I'm going to replace the R's with 5s. Okay, so right here I have 8, capital P, 5. So this is letting me know that I'm doing a permutation where I have 8 objects to choose from, and we're only using 5 at a time. We substitute N with 8, so I have 8 factorial in the numerator. We're going to substitute N with 8 and R with 5. Order of operations, do the parentheses first. 8 minus 5 gives me a 3 factorial in the denominator. Okay, so 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And 3 factorial is 3 times 2 times 1. We could simplify this fraction because the 3's, the 2's, and the 1's will cancel. So what you're left with in your numerator is 8 times 7 times 6 times 5 times 4, which is 6,720. There are 6,720 ways that the vases can be arranged. Okay, so now let's look at a combination. A combination is a grouping of items in which order does not matter. There are generally fewer ways to select items when order does not matter. For example, there are 6 ways to order 3 items, but they are all the same combination. Okay, so if I had item A, B, and C, if order mattered, we would use permutations. So I could do A, B, C, or we could switch the order and have A, C, B. We could switch the order to be B, A, C, or we could do B, C, A, C, A, B, C, B, A. Okay, so there are 6 ways that we could arrange those 3 letters. But for a combination where order doesn't matter, there's only one combination. It's A, B, C. All right. So we have another formula to use when we're dealing with combinations. And here it is. The number of combinations of n items taken R at a time is, and this looks similar to the formula that we had for permutations. So I have a subscript of an n, capital C, lowercase little r here is equal to n factorial divided by r factorial times, in parentheses, we have n minus r factorial. All right, so let's use that formula in an example. before we do that, I did want to highlight when deciding whether to use permutations or combinations, first you have to decide whether order is important. Use a permutation if order matters, and a combination if order does not matter. Right here, you can find permutations and combinations by using NPR and NCR respectively on scientific and graphing calculators. On your Canvas, under the Chapter 11 module, I posted the link for the Desmos scientific calculator, so you guys can start practicing using that, since that's what's going to be available on your CFE, so your county final exam. Start using the scientific Desmos calculator. All right, here's an example. There are 12 different colored cubes in a bag. How many ways can Randall draw a set of 4 cubes from the bag? Step 1, you have to determine whether the problem represents a permutation or a combination. So, does order matter in this problem? No, it does not. So we're going to use the combination formula. We're going to replace all of the n's with 12s and the r's with 4s because we have 12 different cubes to choose from, but we're only picking 4 at a time. Okay, so remember, your bigger number has to be the n. So your numerator will be 12 factorial, and our denominator will have 4 factorial, and then in parentheses 12 minus 4 factorial. Do the parentheses first. Okay, so 12 minus 4 gave us 8. And when we write it all out, we're going to have 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And then in parentheses, the 4 factorial gives me 4 times 3 times 2 times 1. And here we have 8 factorial written out. But then you can simplify your fraction, and everything from 8 to 1 in your numerator and denominator is going to cancel. So what we're left with is 12 times 11 times 10 times 9 in the numerator over 4 times 3 times 2 times 1, and that gives us 495. So there are 495 ways to draw 4 cubes from 12. Okay, so that's all I have for this. I'm going to do another quick video just showing you how to find combinations and permutations using the Desmos scientific calculator. So check it out.